Hmm. Okay. I hope you guys can see this. Boleh nampak ya?
Sudah, Bu.
All right. Okay. Is my voice clear this morning?
Bagaimana teman-teman? Suara Ibu Dr. Nadiah sudah bisa diterima dengan baik? Is it clear?
Masih agak kecil, Bu.
Not yet, Dr. Nadiah.
Okay, I will try. Okay. This is the only thing that I have to help. Okay. Good morning, everyone. Thank you for joining me this morning, and Ibu Asri too this morning. I will be discussing about superheated steam drying method. Okay, so the learning outcomes for today's lecture is for you to be able to understand the principles and the mechanism of superheated steam drying. Okay, and to be able to differentiate between superheated steam and also saturated vapor, okay, in food drying, and also to evaluate the important parameters that are involved, and it's successful implementation in producing seafood. Okay, so these are my reference, but it's not limited to this. Okay, I have a few more that I referred to. Superheated steam drying is fairly new technology. There's not a lot of people that have ventured into this, and the research, any books in regards to this is a bit limited. Okay, so what we have is basically on the scientific articles that have been published by many researchers in regards to this technology. Okay, but basically we would like to know, okay, the first thing first, when we're talking about drying food, is the goals of the drying method itself is basically to remove all the water that is present, okay, that is known as drying, and we need to remove it to a very low moisture content, okay, nearly to a bone dry condition. Bone dry material is a material from which all the moisture has been removed. Okay, so it is being carried out for one or more of the following reasons. Okay, we want to eliminate moisture, which may lead to corrosion, which may lead to product damage, and that eventually can decrease the product stability. We also want to improve any good properties of the material, the flowability, the solubility, the compressibility. Okay, and because when we are able to compress our food product as much as possible, we can manage to reduce the cost of transportation, and the product will be easier to be handled and increase its shelf life. Okay. Sorry, was that mine? Okay, hold on. I need to stop. Okay. Okay. So in addition to all those that we have discussed, we also would like to minimize any chemical or biochemical degradation, and selective removal of water over salt and volatile flavor and aroma compounds. Basically, we want to extract as much of the water as possible from the food itself, so that whatever the structure that your food are in at that time, okay, at its initial sorry, my brain is a bit slow this morning. Okay, whatever the food structure that you would like to retain as much as possible can be retained. Okay, so hence other things that you can do with drying methods is basically to control the density. Control density meaning you are able to take out as much as possible of the water, then the structure of the food is rigid, and whatever left is very dense. Okay, and of course, minimal product loss. We like to minimize as much as possible on the waste loss. So dehydration of organic material or food material is undoubtedly a controlled attempt to conserve or to construct a novel construct that will satisfy functional devotion. Basically, we would like to extract the water as much as possible to conserve or to preserve your food. Okay, but understanding the mechanics behind the drying process is very crucial. Okay, because we are dealing with a very complex food matrices. Okay, and food drying innovations that are available in the market now is including photovoltaic. You also have the thermal imaging, hyperspectral thermal imaging, microwave assisted, and of course, other comparable hybrid technologies. So, according to a recent study, unique food dehydration technologies or the recent advancement of the drying technologies are able to increase drying efficiency by decreasing energy usage, okay, while improving product quality. Okay, so this is the very important thing, decreasing energy usage, because we are dealing with what we call the the global earth warming. So basically, whatever the am I able to okay? So basically, we would like to decrease as much of the energy as possible. So other than that, unique drying methods are able to also reduce any food component degradation and create novel items for customers. What does it mean by creating a novel item? Is sometimes when we dry our product and we can extract the bioactive compound within it. Okay, so we can accumulate as much as possible the bioactive compound. Hence, we are creating what we call a novel functional food. Okay. All right. Okay. So the goals of coming up with new drying technologies is basically to improve on the economics of operation. We need to reduce any amount of energy that's being used. There's more energy is being consumed, more money you need to use. Okay, so you can also increase the capacity and reduce the size of the equipment, and of course to ease the control, because previously drying technologies was a bit complicated and a bit sophisticated. Okay, so not a lot of people know about it, and we need a very specialized experts to work on those drying technologies. But now is much easier, okay, because we have the control system and everything, and because of this advancement of technologies, it is able to be used everywhere, even in the rural areas. Okay. Other than that, we are also considering about the environmental aspects of it. Okay, so to minimize the energy consumption, we can also reduce the emissions or the waste or the heat loss. And of course, we can increase the safety of our technologies and of course the environment that our workers are working in. And also, finally, we are also able to improve the product quality by getting a uniform drying, and that is able to minimize any chemical, physical, or nutritional degradation. Okay. So this is the topic that we are going to talk about today. So this is what it looks like. This is one of the I think this is one of its drying chamber, if I'm not mistaken. Okay, so this one was developed by this company. They call it Exergy in Sweden. Okay, so it was invented by a Claes Munter at Chalmers University in Gothenburg, Sweden, in the late 70s. Okay, so the usage of superheated steam as the drying method instead of air was proposed over 100 years ago, but it was not developed for another 50 years, okay, until the guy Claes Munter found about this theory and tried to come up with this new technology. And it has only been receiving serious attention and acceptance during the past 20 to 30 years. Okay, so drying with superheated steam, okay, as you guys will be known after this as SHS, is an emerging technology with high potential benefits compared to hot air drying. Okay, why? If you look at this temperature profile here, okay, so the superheated steam cooking your temperature very fast in comparison to the normal dry hot air cooking. Okay, so this is one of the reasons, because when you can increase the temperature very fast, then the drying rate will go very fast and you would use less energy, right? Okay, but how do you get superheated steam? Okay, so to be able to get the superheated steam, you need to understand this this diagram here. Okay, this temperature versus enthalpy diagram on the left. All right. So what you have is basically you would see that when the water is being heated from T1, okay, this is the temperature 1, okay, to T2, okay, it would change. It would change from a subcool water, and then it will reach where we call a saturated liquid line. So this line here, from the critical point, is what we call the saturated liquid line. Okay, so this is a saturated liquid line. So what happened is that at phase 2 until phase 3, there's no change in temperature. The temperature is still constant. Okay, and the pressure is also constant. But what happens here, there's a change from liquid into vapor. Okay, so as it moves towards the right, you will get more vapor in comparison to liquid. Okay, until it reaches to phase 3 here, where you reach what we call the saturated vapor line. So what happened at saturated vapor line is that the steam that you will get is considered as a dry steam. Okay, this is sangat kering. So steamnya sangat kering dan sangat panas. Okay, as you add on more sensible heat, okay, add on sensible heat, so the temperature or the phase will change from phase 3 to phase 4. This is where you will get superheated steam. Okay, so unlike saturated steam, okay, saturated steam can be within this wet region here. Okay, unlike saturated steam, a drop in temperature will not result in condensation of the steam, as long as the temperature is still greater than the vapor saturation temperature at the processing pressure. So as long as the temperature is higher than this vaporization point, okay, you can get a constant superheated steam amount or quality. All right. So if you look at this diagram on the right here, okay, so what you have is basically the capability of ultra pressurized superheated steam. So this line here differentiates between liquid and steam. So as your liquid moves towards this part here, okay, in regard to its temperature and corresponding pressure, it will change to a saturated steam, where the quality is equivalent to 1. So what it means by quality equivalent to 1, meaning that the whole of the liquid has changed into vapor only. Okay, there's no more liquid. All right. As it goes on further from the line, and then you will get a superheated steam. Okay. So to generate superheated steam, you have to heat the steam to a higher temperature than its vaporization point. So remember this 0.3 here, okay, it needs to be higher than that. All right. And one is the temperature. It depends on your medium. In this case, you are talking about air. Okay, you're talking about water. Water change into vapor, and from vapor, it changes into superheated steam. So since we're talking about water, what is the boiling temperature of water is of course 100 degrees C. So at 100 degrees C, what you will get is basically what we call a wet steam. Okay, so anything that is under here, under this curve, is considered as wet steam, because it's still a partial fraction of the water being present in liquid form and also in vapor form. But as it goes further on, the saturated steam will be concentrated. Okay, so there's no more liquid, will only be vapor. Then this is what we call the saturated steam. But if you increase or add on sensible heat or increase the temperature of your process, then you will get what we call the dry steam. Okay, no more water. So at this nature of a steam itself, it needs to be wet. They want it to be wet. Okay, so once since it wants to be wet, so it will extract whatever moisture that is available from your food product. So that is how superheated steam drying mechanism works. Since you are dealing with a dry steam, no more water, but it wants water. So it's like human. We need water to live. So steam also needs water to help to live. So it will extract whatever moisture that you can find from the food product, from the surface, from whatever, to make itself wet again. Okay. So the superheated steam acts as both heat source and also a drying medium to take away the evaporated water from the product, and it will produce excess steam. So when the product is separated from the steam, right, the steam will be recirculated in the dryer and reheated to remain superheated, and the process repeats. So in this case, the whole process will be hotter and contains more energy than the saturated steam. Okay. So steam dryer is often a closed operation. Okay, so it's a pressurized system where the wet product is exposed to the superheated steam. So it looks something like this. Okay, so you would have the material inlet up to here. Okay, it will goes into a drying chamber where your superheat steam will come from the bottom here, and then it will mix in the drying chamber. So then this superheated steam will force your dried product to go into this cyclone on the right. So this cyclone will separate your product, okay, as a dried product, and then it will go down into this hopper, and then it will come out in the material outlet. What happened to the steam? So the steam will be going also to the cyclone, but then it will go further up into the condensate valve. Okay, it can be recirculated using the fan. It will go into a superheater, right? Or you can go into a condensate valve where it will condensate. It will turn into liquid. So whatever the liquid that is, whatever the vapor that has turned into liquid will be collected here, and then it can also be reused again within the system itself once it has gone through the superheater system, right? So the steam is heated through superheated surfaces, either using flue gas, steam, or thermal oil as the heating media. Okay, so in this superheater here, they can either use flue gas, steam, or thermal oil. So as the evaporation heat is supplied to the material from the superheated steam, the steam atmosphere is cooled down, but the temperature is a bit, it's not constant. Okay, the temperature goes up and down, but it will not turn into liquid unless we force it to go through the condensate valve, right? What happens for the superheated steam is that it maintains its phase, it maintains its original condition where it will stay as a superheated steam. Okay, so the dried product and superheated steam are separated in the cyclone here, and the steam is recirculated and reheated in a closed loop. In this way, the temperature can be kept constant and the steam can remain superheated. Okay, so this is a general setup of a superheated steam dryer. Okay, so what it needs is basically the 6 things. Okay, these are the very important things. Okay, number one important thing is the steam generator. Number 2 is the drying chamber. Okay, other than that, this is an auxiliaries where we call pipelines. Okay, all this line here, these are all the pipelines. Auxiliary heaters such as superheater, okay, to turn from water to vapor, right? Or to turn water into dry steam. Okay. Hot air supply system, and of course data acquisition and of course control system. Okay, so if you want to imagine what does it look like, this what is going to be it looks like on the right here. Okay, so you would have steamer, and it will produce steam that will move up to the drying chamber and dry the material. Okay, it's a bit complicated. It looks complicated, but it's not. Okay, so bear with me. Right, so remember, number one is the steam generator. Number two is the steam pressure regulator. Right, so it's a knob where you can turn it down, turn it up, you know, increase the pressure or decrease the pressure. It's up to you. Okay, number three is what we call the heating tape. Number four is what we call the steam flow valve. Right, this is again the heating tape. This is number three is the heating tape. So heating tapes is a lot. Right, so number five is what we call a steam superheated. Right, six is the air fan. Number seven is an air heater. Okay, we will discuss why do we need air in this case. Okay, because we already have steam, why do we still need air? Okay, we will discuss about that a bit later. Right, number eight is airflow valve. Again, this is where you have a knob that you can turn, okay, increase the airflow or decrease the airflow. And this is number nine, the most important thing, which is the drying chamber. And number 10 is basically your sample on how you can dry your product here. And number 10 is what we call, number 11 is imbalance, okay, to measure out the quantity of your product. Right, and 12 is a condenser, basically to change from vapor into water again. And number 13 is a collector for the liquid that has been condensated. Correct. Okay, so saturated steam at first was at about 0.58 megapascal, and 160 degrees C was produced in a steam generator at number one here. So when the steam passes through the steam pressure regulator, the pressure will drop. Okay, so the pressure will drop to 0.13 megapascal, and this is where your superheated steam is generated. Right, so the pressure regulator ensures a steady flow of steam through the pipelines and of course to the drying chamber. Okay, drying chamber is here. The flow rate is adjusted by the steam flow valve, which is number 4 here, which is actuated by a computer. So it needs to be linked to a computer. So after passing through the electrical superheaters, which is number 5 here, where the temperature is adjusted to a desired level, okay, the steam goes through the drying chamber, right? So finally, the steam goes to the condenser, okay, and is condensed. And by measuring the condensation rate and knowing the steam properties, the steam velocity in the chamber and the drying chamber can be determined. Okay, so whatever that the flow, whatever that the vapor that will flow out, we can measure them. Okay, so we can measure the steam properties and we can adjust the properties that we want in the drying chamber. The heating tapes that I've mentioned here, okay, number 3 here, we have about this 1, 2, 3, and 4. Okay, the heating tapes on the pipeline keeps the pipe warm and to obviously avoid the heat losses and of course the possible steam condensation inside the pipe. So we need to maintain the temperature all throughout. Okay, and several thermocouples are placed at different points or on or in the pipes to measure the temperature of the pipes and the steam inside the pipes, right? So very important. In addition to that, we have hot air. Okay, so this is a hot air. What it is used is to insulate the drying chamber. So if you could see your drying chamber here, it has a jacketed style, right? Meaning a double layer drying chamber. Okay, so it needs to insulate this drying chamber to maintain the heat that is inside of it. Okay, to make sure that there's no heat going in and out. Okay, so heat maintains inside. Also, it maintains inside this drying chamber, right? So no heat losses. Okay, cannot have any heat losses. So that is the whole point of it. So okay, so the air is moved by a fan and heated by a heater. Okay, and the heating tape on the airflow line, of course, we have the heating tape again. And the airflow rate is adjusted by changing the speed of the fan here at number 6 with a variable auto transformer. And the temperature of the hot air is adjusted using a computer control unit, which turns the heater and the heating tape on the airflow line on or off. Okay. So if sorry, if you could see, okay, this is a mechanism of superheated steam. Okay, so it starts from here, from the bottom here, where you have a saturated steam feed. It is assumed at 100 degrees C and 1 bar, and you would have the enthalpy equivalent to 2,700 kilojoule over kilogram. And then we will change it into a superheated steam, where we add on sensible heat to increase the temperature to 110 degrees C at 1 bar, and we will have an enthalpy that is equivalent to 2720, right? And then it will go to a drying chamber, and then if it needs to be recirculated, it will go back to the steam superheater again. Otherwise, it will be condensated, and it will be exhausted, meaning it will be thrown out. Okay, it will go back to its 100 degrees C, 1 bar, 2690, and then it will be used up again to produce steam, superheated steam. Okay, another important aspect of superheated steam dryer is the drying chamber. Okay, so the drying chamber itself consists an inner rectangular cavity, the inner chamber. Okay, so this is an inner chamber, and of course the surrounding air jacket. So it has a double layer jacket. Okay, so the air jacket ensures adiabatic condition in the inner chamber. Okay, what does it mean by adiabatic condition? Is that, sorry, there's no heat, there is no heat loss, or even there's no heat coming in. Okay, heat coming in pun tak ada. No heat coming in, right? So that's what it means by adiabatic. So the hot air is forced through the air jacket during the superheated steam drying, and could also be forced through the inner chamber for hot air drying by repositioning the airflow valve. So you would have your tray to hold the sample is hung in the chamber by a thin string attached to an electronic balance, okay, which is connected to a computer to allow for continuous weighing of the sample. So you can measure, okay, whatever the water that has been evaporated. So eventually your product would be decrease of its weight, right? Okay, and then a cooling fan is installed between the chamber and the balance to prevent any rise in temperature due to steam or hot air leaking from a small opening in the inner chamber, causing the balance to overheat. So we would have also what we call a thermocouple. Okay, there's 1, 2, and 3. So one thermocouple is inside, okay, at the top. One thermocouple would be at the bottom of your sample, and another one would be at the middle of your sample. Okay, this is just to measure your product. This would be what we call an experimental setup for the superheated drying. Okay, so before we go on any further, we need to also know about the basic principles of drying. Okay, so basic mechanism of drying is basically a combination of heat and mass transfer. So heat and mass transfer are critical aspects in drying processes, where the heat is transferred to the product to evaporate the liquid, and the mass is transferred as vapor into the surrounding gas. Okay, so you would have, if you look at this diagram over here, so the number one step is basically instituting higher temperature and higher vapor pressure. So the heat transfer is basically goes through the material using or via the conduction process. Okay. So thirdly, once the conduction process has done, increasing the temperature of your material, okay, so the mass transfer will transfer the water, the evaporated water, to the surface of your material. Okay, and the mass transport will exchange from the surface to the environment, right? So the drying rate is determined by the set of factors that affect the heat and mass transfer. Mostly it's about the temperature. Okay, sometimes you also have the flow rate of the air surrounding the drying process and so on. But mostly it's about temperature. Okay. What else is the basic principles of drying? Okay, we also have very important things. Okay, two two important periods during drying process. Okay, one is the CRP, which is the constant rate period, and another one is the falling rate period. Okay, so the first step when you want to dry your material, you will go into what we call the constant rate period. Okay, so you go from here first, and then it will directly go to here. Okay, what happened during these two periods? These two periods, okay, during the constant rate period, the surface of the solid remains wet. So that free water is always available for evaporation and the heat and mass transfer can take place at the surface. Okay, so the surface remains wet during the constant drying period. Okay, so accordingly, the resistance to heat and mass transfer are located within the external gas boundary layer surrounding material. So this is the external gas boundary. Okay, external gas boundary. So basically, the product doesn't want to be heated or to be dried. Okay, so the material will eventually trying to resist any extraction of water, any extraction or any increment of the temperature. Okay. And then after that, what will happen is what we call the falling rate period. So falling rate period is that state 2 here, where the surface is no longer wet and the rate of drying will steadily fall. Okay. So this is the basic mechanism or basic principles of drying. Okay. Then we go into basic principle of superheated drying, which is a bit different than the basic mechanism of conventional drying. Okay, so the drying rate for superheated steam drying in constant rate period depends on the heat transfer. Okay, we don't have any mass transfer here. Okay, since there's no resistance to diffusion in its own vapor. So what happens is that the superheated steam becomes it envelopes the product, okay, so it doesn't create any layer of condensation, okay, because it's so dry. So since it's dry, there's no even small amount of water at the surface of the material, okay. So if sensible heat effects, heat losses, and other modes of heat transfer are neglected, okay, and considered negligible, does not appear. So CRP, or the constant rate period drying, is roughly equal to the equation on the right here. Okay, so this is the equation. So basically, you would have the enthalpy of the steam minus the surface and divided by the wavelength, right? And sometimes FRP drying of superheated steam is also higher than hot air because of higher product temperature, allowing for greater moisture diffusion in the product. Okay, but it is not preferred, okay, when we are talking about superheated steam drying. Okay, so because during FRP, internal resistance to the moisture transport is greater than the external resistance. So whatever the moisture will be taken out a lot, and we don't want that, because when the product is too dry, okay, it would be harder to be reconstituted later on. Okay. Another important jargon that you need to know is inversion temperature. Okay, so if you look at this diagram here, where we have a CRP drying rate, you would have two lines. Okay, this is the superheated steam drying, and this is the hot air drying. Okay, this is at the point where it intersects. Okay, hot air drying and superheated steam intersect. This intersection is what we call an inversion temperature. Okay, inversion temperature only defined in constant rate period. Okay, we don't have it in FRP. It's only defined in CRP. Okay, so what is inversion temperature? It's a temperature at which the gas is neither heated nor cool when allowed to expand without using any energy. Okay, so the temperature is constant, so everything is good and dandy. So that is what we call the inversion temperature. So we need, for superheated steam drying, we need to go further than the inversion temperature. So once you are above the inversion temperature, then your drying rate will be faster. Okay, and the inversion temperature depends on the flow configuration and also the flow regimes. So whether you have a turbulent flow or you have a laminar flow, it would affect your inversion temperature. Of course, when you have a turbulent flow, you will have a higher drying rate, and of course, the inversion temperature would be a bit lower than what it is. Okay, so the inversion temperature of many systems are in the range of 160 to 200 degrees C, and in a superheated steam drying, the constant rate period is preferred over falling rate period. Okay, why? Why? Because we would like a longer constant rate period because it can provide higher drying rates, okay, for a longer period of time. So if you look at this diagram on the right, percentage of moisture, okay, so what happens is that at the initial moisture content, it will become, it will look something like this, and the constant rate period would look something like this. So in a superheated steam, we would like for the constant rate period to be a bit longer, okay, so that we would have a longer, higher drying rate, okay, for a longer period of time. Okay, we don't want it to directly go into the falling rate period, because remember what happens during the falling rate period, the surface of your food material is very dry. So once it's very dry, it is not, your product will not be dry uniformly. Okay, there will be a lot more water still inside your food product. Okay, so we would like to have a constant rate period, okay, for a longer period of time, and this high drying rate will increase the efficiency of the processing operation. That would lead to reduction of equipment size and of course the capital cost, and of course you can increase the output of your product. Okay, so what does it mean by no mass transfer? So I've mentioned before that the superheated steam, since it is so dry, it doesn't create what we call a condensate layer. Okay, if you look at this, we compared these two diagrams here. So this one is the superheated steam. This one is the saturated steam. So you would consider this is your surface of your material. Okay, so this is your surface of material. Okay, so what happened is that for the superheated steam, the temperature profile is very rapid and it goes through directly to the heating surface. It does not create any condensate layer because it is so dry. But for the saturated steam, it creates what we call a condensate layer in front of your food surface. So once you have this condensate layer, the uniformity of the drying process is not very good. Okay, so the concept of mass transfer for superheated steam is not valid. So the rate of evaporation from the heat from the surface is only from the heat transfer. Okay, the replacement of air by superheated steam take up the evaporating moisture is attractive in that it provides high temperature heat source. Okay, it provides a high temperature heat source, which also gives rise to a much higher driving force. Okay, we want this. So this is very good if you want to dry your material very fast. Okay, since it does not become saturated at relatively low moisture content as is the case with air. So this is what it means because of this condensate layer here that we do not want. All right. So another point, another advantage of it is that there's no case hardening. Okay, there's no surface hardening of your product, and your product will become more porous, meaning it has a lot of holes on your product. So once your product has a lot more pores, then the uniformity of the drying process will be higher. Okay, so it's easier for you to dry your process. Okay, this is one example. You are looking into what we call a potato slice. This came from Professor Sakamon from Thailand. Okay, Sakamon Deva Hakim. So this is his study. So if you look at this here, this is basically a superheated steam at a glass temperature of 170 degrees C, and this one a superheated steam at a glass temperature of 240 degrees C, right? And this one here is using a hot air and at 170, and this one is using a hot air at 240 degrees C. What happens is that if you look at closely during the hot air, it creates a secondary crust. Okay, so you would have crust here. So this is not recommended. We don't want this. But if you look closely into the superheated steam product, you would have a lot more air pockets. So this is what we call air pockets. So this air pocket that makes your product porous, meaning has a lot of holes. Okay, so this is the air pocket. And the crust is very minimal in comparison to the one that is being dried using the hot air. Okay, and using your hot air, you don't see a lot of air pockets. Okay, it's very small here, but not that much. Right, that is one of the advantage of it. Another advantage of superheated steam is that you would have higher thermal conductivity and heat capacity that would lead to reduced drying time. Okay, so your product will be dried faster. So the material to be dry is introduced to the superheated steam atmosphere where it is heated up convectively, okay, after which its moisture evaporates. So if you look at this here, saturated steam at 100 degrees C, 1 bar, after being heated to a superheated state at 110 degrees at 1 bar, would gain about 30 kilojoule over kilogram of energy. Okay, so that is why it reduced the drying time. So this heat transfer process, it enhanced effectively not only to the material that to be dried, but you can also use it as a contaminating action for microorganisms. Okay, so this effect will lead to inactivation of the microorganism, and of course you can hygienize your product, meaning your product will be very clean. Okay, and despite the high operating temperature, the degradation rate of the product, compounds, especially in foodstuffs, is relatively low because of the short retention time. Okay, we use the superheated steam, lesser time in comparison to the hot air drying. Okay, so due to the low viscosity of the superheated steam, fast penetration of the material is facilitated, and of course the drying principle is effective for materials with porous structure and results in short retention time in the drying process. Okay, so other advantages of superheated steam is energy saving, because it is about 50 to 80% less energy, okay, compared to hot air or flue gases. And because of also the fact that we can reuse the steam, okay, we can reuse the steam within the steam process or within other process in your factory or in your industry settings. Okay, so these savings can be achieved due to higher heat transfer coefficient and increased drying rate in the constant and falling period if the steam temperature is above the inversion temperature. Again, okay, above the inversion temperature. So if you look at this diagram on the left, you see superheated steam at 10 bar and 300 degree would give you an enthalpy that is about 274. Although it looks a bit smaller than the enthalpy of water, the one that we are interested in is actually enthalpy of evaporation. The ability of that steam to evaporate the water within your food material. Okay, if you look at it, the enthalpy of evaporation is much higher in comparison to the water, and also in comparison to the superheat. Okay, and of course, if you compare with annual energy input in comparison to the conventional hot air drying and of course the superheated steam drying, you would use much lesser thermal and of course electricity energy. Okay, another advantages of superheated drying is that the drying itself provides a clean air, okay, and an oxygen-free steam directly in contact with the products we dried, allowing for a better quality, which is in terms of color, nutrient preservation of product that is very, very sensitive towards oxidization. Okay, so the inert steam, okay, so the inert steam meaning the oxygen free steam is also able to prevent any fire and explosion hazards because the pipes are over pressurized, so any leakage, the steam will flow out instead of air coming in. So since there's no air coming in, so you can protect whatever that is inside your pipes, and there's no risk of fire or any explosion in comparison to the hot air drying. Because you know what happens with hot air drying is that once you dry up your material, sometimes it produces dust. Okay, so you would have dust or particulate matter. It's very, very small. And sometimes this dust can create a static electricity that can cause explosion. Okay. So for the superheated steam drying, that does not happen. Okay, so most superheated steam dehydrators are also designed as a closed system where the exhaust may be collected and condensed. Okay, this is the steam. In this way, toxic or expensive compounds are removed and collected before they reach the environment, thus reducing air pollution. Of course, you can minimize the wastage of your expensive compound. And this, in the same way, dust from the process can also be collected. There's a possibility of increasing and reducing the system pressure to reduce the system size or produce useful system for other processes. Okay, the best thing about superheated steam is that it can be used either in high pressurized system or even in low pressurized system. So that's the beauty of it, because the temperature will still maintain the same and it can produce your superheated the same way. And there's always the potential of new product quality specification, where you can see there's a lot of data that is lacking for heat sensitive products. So there's not a lot of drying on the heat sensitive materials yet. Okay, and processing in superheated steam allows parallel, okay, concurrent blanching, pasteurization, sterilization, and deodorization of food products. So you can inactivate your microorganism at the same time dry your product. So you would have two double systems. Okay. And of course, the product can become partially cooked with potentially beneficial changes in textural properties. Okay. This can be used with pasta, okay, to shorten the cooking time. This can also be used in rice, okay, to again shorten the cooking time. And of course, it can change the texture a bit. So for the people that like that type of product can use that. Okay, but talking about advantages, there's also limitations to the superheated steam drying. It is often a complex system and it is a bit costly in comparison to the conventional hot air system. And there's always a risk of air infiltration. Air infiltration meaning a leakage to your piping system. So when the amount of air in the dryer is increased, the dew point of the exhaust steam decreases, and therefore the heat recovery becomes a bit difficult. Hence why, if you look at the previous system, they have a lot of heating tips. Okay, and the main sources of air infiltration are the feeding devices. Therefore, most feeding devices such as screw, rotary valve must be redesigned to be perfectly airtight. Okay, so that means no heat losses and there's no risk of leaking of anything, right? Another thing is about higher product temperature. This is a bit of an issue, but then using a vacuum drying is the most suitable solution. Unfortunately, vacuum drying is a bit more expensive because of the design complication and of course, higher capital cost. And under vacuum drying, the exhaust system cannot be recovered below the boiling point of 100 degrees C unless the exhaust system is recompressed. So that is why it has a higher capital cost because there's more things to be added to the system. Okay. Moreover, vacuum drying significantly decreases the drying rate and making dryers much larger for a given duty. So this one is a bit of a limitation to your superheated steam drying. Another thing is that corrosion, okay, damage to your equipment, where elevated temperatures, high speeds, and superheated steam can often load it with corrosive materials or chemicals from the drying product, and it can cause also material corrosion within your pipeline. So dry corrosion enables deposit of reaction product and organic growth, can create microbial growth and everything. So strength, resistance, and type of material must be chosen carefully. Okay. Other limitations is we are talking about initial condensation. If when we are discussing about a case study about food application later on, you can see that the initial condensation are often the limitations of superheated steam drying. Because what happens is that the product before it's been dried, it would absorb the water from the steam itself. So the initial condensation will increase the moisture content of your product before it goes down. Okay. and products that may melt, undergo glass transition, or be damaged at saturation temperature of steam cannot be dried in superheated steam dryer. And products that may require oxidation reaction to develop desired quality parameters cannot be dried in superheated steam dryer. And of course, the cost of auxiliaries, meaning the feeding system, product collection system, the piping, and the exhaust system is adding to the capital cost. And we're just not buying the steam generator and the drying chamber, but we are also investing a lot of money on the piping system and so on. Okay. Do we want to have a short 5 minutes break, Ibu? Can we have? Okay, I think we can have a short 5 minutes break for you guys to go to the toilet or drink some water, something. Right?
Yeah, thank you, Dr. Nadiah. We will have a short break.
All right.
Okay, Dr. Nadiah, you may continue your presentation.
Okay, thank you very much. All right. So further classification of superheated steam drying can be found based on three things, on three parameters, sorry. Okay, so the first one is the pressure, second one is the temperature, and of course the third one is based on the moisture content. But we mostly focus on the the parameter on pressure. Okay, so you would have vacuum pressure, okay, and you would also have the atmospheric pressure and the above atmospheric pressure. So based on temperature would have a low temperature below 100 degrees C, and medium temperature and high temperature, depending on the type of products that you would like to produce. Okay, so you also have on the moisture content, on the low moisture content up to 40%, the wet basis, medium moisture of 40 to 70%, and of course the high moisture above 70%, which is usually used for spray drying of milk, solvents, and other effluents. Okay, so we focus on the pressurized technique. Okay, the first is the high pressure superheated steam dryer, where one of the main application of this pressurized superheated steam dryer is to dry press big pop after extraction of sugar. So it can be operated at a pressure of about 5 bar, and it consumes about 50% less energy than the conventional dryer. So of course, you would have the product quality that is much better than comparison to hot air in terms of the appearance, the texture, the digestibility. Okay, and pilot tests for fat green from brewery, alfalfa, fish meal, pulp from citrus has also been used with this high pressure spray drying. One of the biggest company, okay, which is the founder of superheated steam dryer, the Klaus Munter from Swedish University. So he come up with this company, Exergy Steam Dryer. Okay, so the products that has been dried using this Exergy dryer such, there's a lot of products. Okay, so the examples of added value Exergy dryer is that it can increase protein value, okay, in terms of bypass protein value in cattle feed. It has less taste change in terms of drying and expansion of tobacco without change of taste and quality. Sterilization, okay, because of the high temperature, high pressure, okay. You can also increase oil yield in from vegetable oil, okay, from oil seeds, chemical recovery, and of course energy recovery. Okay, another techniques of superheated steam dryer is the low pressurized. Okay, so this one was taken from Prof. Sakamon Devahasi from King Mongkut Thailand University. So this is from his lab actually. So he has done this for low pressure superheated steam dryer. It is basically to combine the ability to dry product at low temperature with some advantages of superheated dryer. Okay, and the dryer is operated at a reduced pressure, which is between 5 to 10 kilopascal, and the steam will become saturated and eventually superheated at a lower temperature. It is suitable for high sensitive products such as herbs, fruits, vegetables, and other bioactive materials. In near atmospheric pressure, superheated steam dryer is where most superheated steam dryer are operated in this range of pressure. Okay, so wide variety of products was dried successfully. Okay, for instance, potato chips, tortilla chips, shrimp, paddy, and noodles. Okay, and it has a better product quality in comparison to air drying. Okay, so when you look at the food quality and the superheated steam drying, okay, this one is for apples and bananas. You can see this is the hot air drying for apples and bananas. The apples still looks a bit shiny, not shiny, clearer, okay, brighter in comparison to the hot air drying. And of course, the brownie effect for the bananas is much lower in comparison to hot air drying. Okay, so the banana slices using the low pressurized superheated steam drying, okay, still retains as much of its structure and the color of it. Okay, and if you look at these comparison between carrot cubes for low pressure and of course vacuum drying, so the dehydrated product looks much better. Okay, and of course the dried product also looks much better in comparison to the vacuum drying. Okay, and of course if you look at the microstructure of it, okay, so this one is undergoing the low pressurized, okay, and this one is using the vacuum drying. So again, if you look at it closely, it has a lot of air pockets in comparison to the ones in air drying. Okay, the air pockets is a bit small, and you can tell that the product has been shrink a lot. Okay, and the same can be seen in this picture on the right here. Okay, so other food quality when we're comparing vacuum drying and hot air drying is the beta carotene retention. Okay, this one is under the again using carrot. Okay, so the beta carotene is the vitamins that is inside the carrot, which is very useful, that shows the color, the orange color of the carrot itself. So if you look at the low pressure system, the moisture content is the beta carotene content is still quite high, okay, for the temperature at 60, 70, and 80, but in comparison to the hot air drying, it's a bit low. Okay, so the degradation of the beta carotene can be seen very much in the hot air drying, but in the vacuum drying is more or less has the same the same pattern, okay, as hot air drying. Okay. Another aspect when we're talking about inactivating microorganisms is the food safety and superheated steam drying. Okay, so this is the fresh sample, salmonella on a cabbage surfaces. Okay, so this would be the salmonella. Okay, this is for the fresh sample. So if you look closely, it's quite perfect. The rod, the overlook, the looks of the salmonella itself. But if you were to use hot air drying, the salmonella is a bit destroyed, as you can see here in the highlighted in the circled one. As you can see, it's a bit destroyed, but there's still many that looks a bit that still looks good. Okay, so you can see here, still looks good. This one here. Okay, in comparison to the vacuum drying, you can see the spore that has been introduced or that has damaged the salmonella microorganism. Okay, you can see, but there's still the ones that are a bit resistant towards the vacuum drying. But if you look at the low pressurized superheated steam drying, almost all of the salmonella is destroyed and is damaged. Okay, so it's broken down and there's spores inside here. So what happens is the microbes cannot be regenerated again. Okay. Okay. So how do you measure the performance of superheated drying? Okay, this is some method of it. Okay. So this is a very easy method you can compare. Okay, so you would have the method 1, method 2, and method 3. So method 1, what does it do is it uses the saturated steam at temperature of 100 degrees C and time of 10 minutes of treatment. And then it uses a hot air drying of a temperature of about 80 degrees C and air velocity of about 2 meters per second. And then at the end of it, you will get your product. All right, for method 2, you would use your raw material to undergo a superheated steam at a temperature of about 120 degrees C, 130, 140 at 5 minutes, 10, and 15 minutes at a pressure of 1 bar. Okay, and after that, it will go through the hot air drying at a temperature of 80 degrees C and air velocity of about 2 meters per second. Then you'll get your product. For the third method, the microbial inactivation, and of course the drying method of it, is combined into one process, okay, which is using the temperature of 120 until 140 at a pressure of 1 bar. And then at the end of it, we'll get the product where we compare all of them together. So the parameters that has been determined or measured is the water activity, the moisture content, the total plate count, the yeast mole count, and of course we want to know the processing time. Okay, so we look at the first method, which is we had the saturated steam treatment and the hot air drying. So the RM is what we call the raw material, which is the control material. Okay, so at control material, the water activity is about 0.171 and the moisture content is about 12. Okay, at the total plate count is about 1.3 and the yeast mole count is about 1.1. Okay, if you look at it closely, when you expose your product or your raw material to the saturated steam treatment, the water activity is about 0.85. The content also has increased. So when you have an increment of this, you would get a very high drying load, meaning it would need you a longer period of time to dry your product to a moisture content that you would like it to be. Okay, but in terms of the total plate count, okay, it's not detectable, and this is also not detectable. For the hot air drying, it managed to lower down the water activity to 0.2, and of course, the moisture content is about 5. But the processing time it takes for you to get this value is about 220 minutes. Okay. For method 2, where we use the superheated steam and of course the hot air drying at 15 minutes, okay, and 120, 130, and 40, you will get at approximately about 0.5 to 0.3, okay, water activity, and about moisture content and averaging about 8 to 9%. Okay, but the processing time is still a bit high. Okay, you could see this is the 205 minutes, not much difference between these two. Okay, and then it lowers down a bit to 155, and then it lowers down a bit to another 205 minutes. Okay, if you were to compare for superheated steam drying, okay, for the combined interaction between the microbial inactivation and of course the drying process, at 120 degrees C, 1 bar, 130 degrees C, 1 bar, and 140, you will get at almost a constant or an average of water activity and moisture content. That is a bit constant. As you can see, it's not much of a difference. But the processing time is very, very low. Okay, at 140 degrees C, the processing time is only 30 minutes. In comparison to the same amount of value that you would like it to be, where the TPC and YMC at a non-detectable amount, the processing time is about 220 minutes. Okay, so this is the advantage of superheated steam drying. Okay, that is why we would like to move forward with this type of drying. Okay, so now we look at the application in food. So these are some examples of it. Okay, but superheated steam, of course, is not limited to this example for me. Right, so you would see sugar beet pulp. So basically, you want to extract sugar from it. Okay, and then once you get the extraction, you would have pulp or the wastage of the beet just now. So what we like to do is to dry them up so you can compress, you can feed it to animals, okay? You can use it for other types of products. So the drying kinetics in superheated steam and hot air was studied in thin layer. The thin layer is very important because for you to establish your kinetic modeling, so you need to dry your product in a thin layer first, so you can create a reference or benchmark that you can compare against to later on. Okay, so for 3 temperatures, about 150, 157, and 183 degrees C. And the 3 drying medium velocities are about 0.2, 0.32, and 0.37, all under atmospheric pressure. So the samples initially gain a small amount of moisture. This is what I meant by initial condensation before, the limitation of superheated steam drying. Okay, so depending on the temperature in superheated steam, due to condensation before the samples warm up to the steam saturation point. So beyond the steam saturation point, you will get the dry steam, then all the moisture will be taken out. Then the moisture content of sugar beet pulp change faster in superheated steam than in hot air drying at the same temperature. So if you look at this here, so A, B, and C. So this is your 130 degrees C, B 157, C 183 degrees C. You can see the constant rate period is a bit longer in the C patterns in comparison to the B and the A patterns, right? And by increasing the drying medium temperature from 130 to 183 degrees C, the drying time was decreased by 48%. And for superheated steam, but only by 34% in hot air drying. So the velocity had no effect on the drying rate in hot air, but the effect was significant in the superheated steam, where an increase from 0.2 to 0.3 increased the drying rate by 27%. So the parameter for superheated steam is not only depends on the temperature, but also depends on the velocity of that superheated steam. So that's why I mentioned before this, if you were to get a turbulent airflow, it would be much better, okay? Because your inversion temperature would be lower, then you can get beyond that temperature to gain your superheated steam. At the same velocity, the drying rate increase with increasing temperature and higher in superheated steam than in hot air. Okay, so the same pattern you can see in potatoes drying. Okay, so this one is the drying kinetics of potatoes for a single cylindrical sample, 5 millimeter in diameter and 30 millimeter long for 3 temperatures, 125, 145, 165. So at one velocity, there's only one velocity in this case. We don't, these authors did not vary, okay, the velocity of air. So an increase in steam temperature from 125 to 165 decreased the drying time by 60%. Okay, and during drying there was a constant rate drying period at 125 or 145, but no discernible constant rate period at 165. Okay, and this was probably due to immediate surface hardening or increased thermal driving force, as with the sugar beet pulp. Right. Another example is the Asian noodles. If you look at the under atmospheric pressure, and the increasing temperature of the steam increase the drying rate, and it can decrease the drying time. Okay, at temperatures above 130 degrees C, a partially cooked instant noodle was created, but there was an unacceptable browning of the noodles. Okay, so above 130 degrees C is not recommended for the noodles because there's a browning effect. But at 110 and 120, improvement in the noodle textural parameters, where the adhesiveness and the gumminess was much preferred by the consumer. Okay. Okay, so what are the advancement of a superheated steam drying? Okay, the best part about superheated steam drying is that you can combine. You can combine with other conventional drying equipment. Okay, so number one is the pneumatic conveying dryer. So you would have your material on a conveyor. It will move into your pressurized vessel or pressurized drying chamber, and then where you the product would meet with the steam at about 170 degrees C with a pressure of 1 bar. So it will move from one point until it goes down a bit further to this, and then it goes down to the third level where your product will come out at about 110 degrees C, and the moisture content will be much lower, right? Another method is to combine superheated steam with the fixed bed. Fixed bed, you would have your feed will be coming from here, and it will go to this piping method, and then all the steam would be would be in contact with your food material. Okay, and then it will go down to the cyclone to separate between the product and of course the steam. The residence time is about 5 to 60 seconds. Very, very, very fast. And the generated excess steam, 1 to 5 bar, can be reused either directly or after reboiling. And if there is no external use, the excess steam can be recompressed to 10 to 20 bar and used as the existing media. And the power consumption is about 150 to 200 kilowatt hour per ton of evaporated water. And about 70 to 90% of energy recovery is possible. Okay. Another method is to combine with a fluidized bed, right? So this is a fluidized bed where you have a press pulp goes into here, okay? And then you would dry your pulp. This is your drying chamber, okay, where your steam would come from the bottom here, okay? So and then the dry pulp will come out to this outlet, right? And whatever the particulate matters can go to this cyclone, okay? Right, so it is a closed system. It is used to dry materials products produced in brewery, in food and sugar processing, and of course in wood-based biofuel. It has a very close to 90% energy recovery as steam at 2 to 4 bar and no product oxidation whatsoever. Okay, this is another method. A flash dryer. So flash meaning the superheated steam will be in contact with your food product in a flash. Okay, it's very, very fast and a very, very short period of time. So a flash dryer is a system in which a wet powder is introduced into a hot stream of air. And usually this is done by throwing the wet material into a very high-speed airflow in a venturi using a mechanical dispenser. So the powder has a large surface area surrounded by hot air. And since the powder is wet, the hot air can easily evaporate the water at the particle surface, simultaneously cooling the air down and carrying the water vapor away in airstream. So it is widely used in industrial settings due to its ability to process material very quickly and effectively, so you would have high volume production. It can be achieved extremely fast, okay, and often within seconds, and can help to minimize risk of contamination because of the simplicity of the design, and the design can, the equipment can be clean, easier, and of course it is versatile, high thermal efficiency, compact footprint, and easy to clean, and it is made for a heat sensitive product. Another method that is a bit the same as the flash dryer is what we call the impingement dryer. So impingement dryer consists of a single gas jet or an array of such jet impinging normally on a surface. So you would have this single gas jet. So you would have this gas jet that would go through your product. Okay, so this is the nozzle. So your superheated steam will come out here, right? So this is a single nozzle. So you can see the superheated steam will come out here, and you can create what we call a turbulent flow. Right, so there's a great variety of nozzles can be used, and selection of nozzle geometry and multi-nozzle configuration have important relevance on the initial and operating cost, and of course the product quality. So the more that you have on the nozzle, the more cost you will incur. But again, the offset of it, you would have high production volume. Okay, so rapid drying, popular for convection drying, and large variety of nozzles are available, and the temperature and jet velocity in impingement drying may range from 100 degrees C to 350 degrees C, and the velocity is about 10 to 100 meters per second. So granular products such as coffee beans, cocoa beans, rice, and nuts dry faster and more uniformly when using impingement dryer due to the pseudo-fluidized bed created by the high velocity air from the nozzle. And the product generally bake faster and more uniformly in conventional ovens, and the air impinges at high velocity on the product surface, removing the boundary layer of moisture. Okay, and cold air thus greatly accelerating heat transfer and reducing process time. Again, remember it doesn't have any condensation layer, so that's what it means. air is continuously recirculated for removal of the moisture and releasing. The use of superheated steam in impeachment drying may be considered to improve the texture of the food product, and steam may cause changes in the texture of the product during drying, thus in producing a crispier product after frying that in comparison to the hot air drying. So you can produce a crispier product after you dry them even more crispier than the hot air drying. Okay, this is another technology that is that is gaining traction, okay, very fast, which is the spray dryer. Last week we have discussed about the spray dryer, right? So in this case, instead of using just the simple hot air, it uses a steam, okay, instead of a hot air. So spray drying is widely used in industry, even though its energy efficiency is often low. So substitution of air, instead of using a hot air, but we use a superheated as a drying medium, in spray dryer may reduce the energy consumption by 20 to 30%. So if the excess steam generated by the moisture evaporation is upgraded to a higher temperature level and reused for drying, and the energy demand can be decreased by even 80%. So this is the best part about using superheated steam with your spray dryer. So these are the method of it. So you can see the process step, which is the superheated steam that is about more than 100 degrees C, where your feed will come in and it will meet with the superheated steam, and your product will be dried faster here. And then at the second process step, you would dilute the steam, okay? So your relative humidity would be lesser than 90 degrees C, 90%, sorry, and the temperature will be less than 40 degrees C. And at the process step 3, the powder will discharge at a temperature less than 35 degrees C. Okay, so spray drying with a superheated steam was successfully applied for both thermally resistant and wide range of thermally sensitive material. So higher particle porosity due to rapid moisture evaporation result in improved powder rehydration properties. Okay, so products or like instant coffee that is used with this technology will be, it's easier to be diluted with water. Okay, when you want to make coffee, instant coffee that's been dried with spray drying with the superheated steam, it's much easier for you to dilute them in water. So it can also be applied for in situ particle crystallization, meaning if you want to increase to decrease the crystallization sizes and shape in order for it to be solid, higher, for it to have higher solubility, then you can use spray dryer. A comparison of the results, okay, comparison between spray dryer with SHS and standard hot air showed the product recovery is about 49%. Okay, but for hot air dryer is only about 37%. Okay, morphology for the maltodextrin obtained with superheated steam with spray dryer was described as a spherical particle with inflated skin. Yeah? So it looks very nice, very rounded shape. Okay, due to rapid moisture vaporization. But if you were to use hot air drying, so the maltodextrin is opposite from the superheated steam, where you can see wrinkled surfaces, which indicates a slow evaporation rate. So the possibility to apply superheated steam spray dryer to heat-sensitive dairy products is recommended. Steam milk concentrate, lactose, whey protein isolate, micellar casein concentrate, and of course other food products. Okay. So in summary, basically, superheated steam dryer is more effective in shortening drying time and improving product quality. It is often found to have higher energy saving in comparison to other conventional drying methods. And of course, the short drying time and low final moisture content can be obtained when the high temperature or high velocity of steam were applied. So if you look at the diagram on your right, okay, the performance indicator can depends on the specific energy consumption, cost, the quality attribute that you would like for your food product, scalability of your equipment, the environmental effect or the impact of environmental impact of the superheated steam itself in comparison to hot air drying, Okay. Cost index, the drying rate, and the drying time. So these would be your performance indicator. Okay, for you to justify if you wanted to use superheated steam in comparison to hot air drying. Okay, so that ends my lecture for today. Okay, if any one of you have any questions you'd like to discuss or anything that you don't understand, please, we are going to open the session for about 10-15 minutes. That's okay?
Yes.
Okay. If sorry, if you don't have any questions, maybe we can proceed with quiz. Okay, I have a short quiz with 15 questions in regards to the superheated steam drying. Okay, you can use this QR code to scan to go through the Google form.
How much? Berapa menit ya Bu ya untuk presentation?
We can
10 or
10,
15?
yeah, 10 to 15 minutes.
Okay.
That's okay. All right.
Silakan mahasiswa untuk scan barcode dari quiz Ibu Dr. Nadia.
I hope you guys can. Let me know if you cannot access this quiz. Okay.
Oke, teman-teman mahasiswa, sudah selesaikah? How many minutes left? About 5, maybe, Dr. Nadiah? 5 minutes more?
Sorry, Ibu?
Yeah. 5 minutes left for
Okay.
quiz. It's okay.
Yeah, sure, no problem.
Uh, Okay, Dr. Nadiah, maybe the student has already completed the quiz.
Yeah.
How many students submit the quiz already?
Okay, hold on.
5 or maybe
More.
less than or more?
More. 11.
Okay.
Uh,
Okay. And how about the last quiz? Is it complete or maybe only few students who complete the quiz last session?
Let me check last session.
Because I need the mark for assignment for students. So if the student didn't complete the quiz, so they have to pay attention about it.
So there's no mark for them.
Yeah.
Okay, for last week it's about 15. So including you. So the whole class submitted already.
Okay. Good.
Maybe I can email you the response,
Yeah.
the result.
Thank you.
Okay, please I will do it.
Student mahasiswa silakan segera mensubmit ya karena maybe we cannot accept the response after class ya Dr. Nadia ya. Maybe we will close the response. So if you submit the quiz after class, but 11:30, so it's not record in Dr. Nadia because okay, already submit, all of the students already submit. So we move to the Q&A before uh, we close the session. We have Q&A about 13 minutes. Okay, is there any question from the student, or you may want to know more about the FHS or Superheated Steam drying in Malaysia? You may ask Dr. Nadiah. Is there any? Vicky, maybe you want to ask? Gali? Raihai? Or Widya? So please, kalian juga bisa bertanya dalam bahasa Indonesia, gitu ya. I will try to, yeah, I will try to translate to tadi ya. Jadi silahkan, nggak usah don't hesitate to ask in bahasa or in English, yeah. Okay, if we wait the question from the student, I will ask you, Dr. Nadiah, about the microstructure after the product applied by superheated steam. So I see in the picture there are many air pockets more for show in the microstructure of the product. Is it beneficial for us or not? Because I thought a bit about the shrinkage of the product. Yeah. For example, if we have dried oyster mushroom and we want to rehydrate the product, so it will be back to the nearly the fresh look like this. So the shrinkage ratio is high. But if we have the product with a lot of pore, is it good for the product, or maybe it will destroy the texture after we rehydrate it?
I think it depends on what type of the end product that you like. Okay, for instance, you're talking about instant coffee powder, then it would be good because it's easier for the product to be soluble. Okay, so if you're talking about maybe a rigid structure of carrot, sometimes it's good too, especially when you want to dry them and then later on you want to use it in your soup. Maybe then you want to put it in your chicken curry or something like that. So it's good. From my understanding is that superheated steam, although produce a lot of pores and the air pockets, but the condition or the structure of the product does not different uh, from the original one, because it creates like a smooth structure, and kalau di Malaysia we call it gebu, like cantik rupanya, dia tak ada wrinkle-wrinkle. Okay. So yeah, superheated is good in the sense that because sometimes our consumer, they like to see a good product, right? So they would like to see something that looks very similar to the original one. So yeah, I think the consumer preferences plays a very important role too, in regards to whether you want the end product to look nicer or not. So yeah, using superheated steam would help so much in that, in terms of the shrinkage. It's lesser because of the air pockets. And there was one of the advantages of using it too, because in potato slice, it creates those air pockets, so that when you want to fry them, it would create a crispier product. So the air pockets will help in absorbing the oils and fluffing it up, making it fluffy. I hope that answered it.
Yeah, yeah. So it will turn the texture into the crust and the core.
Yeah,
Yeah.
yes, the crust and the core.
To the Nadiah. For the interesting presentation. And I want to ask again about is there any drying? Sorry, is the FHS or superheated steam drying affected the quality of the product from the color, nutritional value, the sense of the that of texture, there is differences of the fresh and after processed with the type of
Okay, I think I understand a bit of your question. Sorry, my lines here is quite bad, so your voice is a bit slow. But I think I get most of the gist of your question. Okay, in terms of texture, in terms of color, nutritional quality, retention rate for superheated steam product is much higher than the hot air drying, because again, depending on the pressure that we use, especially for the low pressure one, it can retain as much of the color in terms of the texture, and sometimes you can even extract the bioactive compound to the surface, so you get more bioactive compound that is available to your to your stomach. So meaning, if you were to consume the product, you would gain more vitamins out of it. Okay, so superheated steam, in a sense, not only would help to retain as much of the original look of your product, but also can in fact extend it to increase the bioactive compound that is very beneficial for your health. So that is why there's a lot of research that has been done at the moment to use superheated steam drying to dry the herbs, especially beneficial herbs such as tongkat ali, ceko, acik fatima, those sort of things in Malaysia. So they would retain as much as possible of the vitamins and whatever the bioactive compounds that are available. So that is not, you're not eating what you call just the fiber, but you are eating a beneficial part of it.
Thank you, Dr. Nadiah, for the explanation about the effect of drying. Okay, and when we want to select this type of drying, superheated steam, I think we also have to highlight it about uniform and also for fast drying. Yeah, but in other case, in hot air drying, we may found a case hard in the inside of the product, especially if you want to dry grain and also cereal product.
Okay.
So I think in Indonesia for the application of the superheated steam is very limit, very
I think it's more or less
limit.
the
But
same, yes. Uh, in India, they use the superheated steam to make those parboiled rice.
boy,
Yeah. So basically, parboiled rice is they can extract as much of the starch possible from the rice itself. So the rice that you will be eating later on would have a lower GI index, glycemic index.
right?
Yeah. So it has been used extensively in India, especially in basmati rice. So it is a good option, especially for diabetic person to eat those rice. So that is one of the advantages of the superheated steam dry. Even I don't think in Malaysia we have that too. But then again, I may need to go to the industry itself lah, to see whether or not. But in India, pharmaceutical, yes, they have used that extensively. Um, I think most of them acquired the equipment from Sweden. There's also products from United States. So yeah, and I think partly because Malaysia, we shy away from those technology because they don't have the experts for it. So once you don't have the expert, yeah, so it gets a bit scary to adapt new technology if you're not used to it. So I guess yes, that's why. I think it's the same for Indonesia, right?
Yeah.
Satwa.
Okay. Yeah. It's very challenging
Very challenging
technology.
job.
Yeah.
Yes.
Instead, they have many advantages, but it also has more things to be comprehend.
Correct. It
Yeah,
needs a lot more to understand,
yeah, to
especially
understand.
on the superheated steam and the thermodynamics part of it.
Yeah,
Yes.
the thermodynamic mass transfer also
True,
very
true.
complicated, I think, for
Yes.
students maybe to understand this type of
But
drying.
having this discussion is a good platform for the students to know about the advancement of the drying technology, because we are so used to the drying technology, the conventional ones, using the hot air, using the solar. So yeah, we are so used to that, and I think every time when we're talking about drying, it embeds into their mind that that is the only method available. But there's so much advancement in technologies, except of course, it's not being, it's not being adapted yet in the country. But it's good for them to learn about this, so that if ever they go outside and find a job, then you are quite prepared for it.
Yeah, and I see that drying industry is get more attention today. Yeah,
Yes.
in terms of wood and also peat product, they use
Yeah.
drying for the
Yeah, to
processing.
be very honest, previously there's always a lot of talk about drying, degrading food products. You are just eating the fiber part of it, no vitamin C anymore, those sort of thing. So that's why we moved to the non-thermal processing area, because we want to retain as much of the quality and the nutritional benefits of our food. But then again, I think the drying, the innovative drying technology are coming into play, because why? I think the fact that in comparison to the non-thermal technology, is much more easier to adapt to the combination of advancement in terms of the drying technology in comparison to the non-thermal. Non-thermal, you're talking about the experts, you are talking about new technology. We're also talking about a very, very high capital cost. So hence, yeah, I think besides, they already have the drying technology here, so might as well just upgrade, yeah, instead of going through the new route altogether.
Okay, thank you for the insight of the drying. Okay, is there any question from the student? Not yet. Okay, I think Dr. Nadiah still have assignment for the next week. Do you want to
Yeah.
explain about the assignment for the next week? You may very
Okay. Okay, for next week, you guys are supposed to do a presentation, correct? Okay. So the presentation, the title of your presentation may come from infrared, may come from microwave technology, may come from fluidized bed technology. Is that true? Okay. So there's three types of technologies that you can play around with. Either you can go for the single type of drying technology, or you can also venture into the combined drying technology. Okay, then maybe sharing input of other types of drying technology may increase knowledge of your other friends. And me too. I could also learn from you guys. So there are a lot of types of technology and the combinations of it. Okay, so there are the infrared heat pump drying, there's the infrared convective drying, microwave convective drying, and vacuum drying. I think there's 14 of you guys. You perhaps can divide into 3% per group and then decide on the title, preferably not the same with the other group, okay, so that we can learn a bit more on the drying technology that perhaps maybe Ibu Asri and myself are not available, do not have enough time to discuss with you guys. So maybe we can share. We make it into a sharing session. You don't have to be so formal about it. Okay. So the one group is given 15 minutes to present. Okay. I would like for you to include the introduction part of it. Know what is drying all about. To gain more insight on it. And of course, I would like for you to discuss on the mechanism and the principles, the advantages and the limitations and applications to food, and of course, the recent advancement. If you can find any, company that is commercializing the method of drying that you are discussing, then we can present that too. And then we give a 5-minute session for Q&A. Maybe Ibu Asri and I can ask any questions, or maybe even from your friends can ask any questions too. Okay, so that would be the assignment for next week. All right. Okay, so there's any type of the combined technology. Okay, if you want to present about the two-stage fluid beds, vibro fluids, flash fluid bed, there's a lot you can think of. All right. So I think that would be all.
Okay, thank you, Dr. Nadiah. Before we close the class, is there any question for the assignment, students? So you better record your presentation and then share the YouTube with the presentation session. So it will not be disturbed by the connection.
Yeah, hopefully, yes.
So that you record before the presentation. Is it clear to them?
Yeah, I think they understand.
Yeah, understand. Okay, yeah, Dr. Nadiah, thank you again for sharing.
No problem. Thank you very much. It's an honor to share the knowledge with you guys.
Yeah, okay, thank you. But before we close the session, I hope all the students can open up the camera. We have documentation for the end of the class. Yang belum, siapa ya? Silakan. Boleh. Okay, ready? 1, 2. Thank you, Ibu Dr. Nadiah and myself, our student. We meet again next week with the class presentation. Thank you.
All right. Thank you. Take care, everyone.
Assalamualaikum.
Salam.